Welcome everyone. Today we're going to start talking about interference. What I have for you today is two sine waves that are identical to each other. I've drawn these two waves over here, and our task is going to be to add together the waves to see what the resulting type of interference is. To add two waves together using superposition, you simply have to look at every point in space. I've also chosen a certain instant in time. For convenience, I chose t equals 0. So that means that this part of the wave in the sine argument will go to 0. So we're just graphing sine of kx. They're identical waves, so they have the same amplitude ym. They have the same wave number and angular frequency. So you can see that these waves look identical over here. And so when I go to add them up, I will add 0 to 0 over here, and then as I go to the right, I'm going to get a slightly bigger value on the sine function, slightly bigger value on the sine function, until I get to the peak. The peaks here are overlapping, so I'm going to get that the two peaks sort of add together. So if I were to go over here and draw a quick example of what the sum of these two waves looks like, I'm going to get a duplicate of the wave that I've drawn, but it's going to be bigger because every single point is twice as far for the wave as a whole as it is for any individual point on the wave. Now, because both of the waves that I've added together have the same k and omega, I get exactly the same shape profile of my final wave. And because the amplitudes are the same, I get exactly twice as much amplitude out of the final wave. In fact, you can go add these directly by just doing this equation plus this equation. And because they're the same, you're going to get 2 times the whole equation. So we can see that we can do this addition graphically to get a picture like this. And we can do this addition symbolically to get a final equation. Now this, as you might have guessed, is an example of maximum constructive interference. There's no way that I can orient these two waves to get a bigger resulting wave over here. All right, so now I have changed the second wave by adding an initial phase of plus pi. What that will do to the graph is cause it to be shifted to the left because I chose a positive initial phase. And you can check that. Again, we picked t equals 0, so we don't have to worry about the omega t. If you check at x equals 0, for example, what you'll see is here you get sine of 0, which is 0 right there. Here you get sine of pi, which is also 0, right? So we still have a 0 point here. And then you can check this very first spot here by looking to see, if I pick kx to be pi over 2 up here, we'll have sine over pi over 2, which is 1, which is at a maximum here. If I pick kx to be the same value of pi over 2 here, I get pi over 2 plus pi. The sine of 3 pi over 2 happens to be negative 1, so I should be at a trough where this one is at a crest. So I know that I've shifted my wave correctly here. I think it's a lot easier to add these particular waves up graphically. And the way I'm going to do that is I'm going to look here again, 0 plus 0, so that one's obviously 0. And then as I go positive on the first wave and negative on the second wave. And because they have the same amplitude and the same wave number and the same everything, I'm going to get that whatever value I'm at up here, positive, I'm at exactly the same value negative over here. So if I go to draw the resulting wave here, it's kind of boring. I just get 0 all the way across the board. And this is an example of complete destructive interference because the waves, even though they were both here originally, are gone when I add them together. So this is another really common example of interference that we'll make use of a lot. Now, one interesting question is to really think deeply about where this interference came from, because all I did to go from this wave added to itself to this new situation with destructive interference was to add an initial phase down here. And so the key in looking at these two waves as to whether you get constructive interference or destructive interference is to look at what's called the phase difference between the two waves. Now we'll typically call that delta phi is the phase difference between the waves.